Hello students. After a long break, here we see again through a new video lecture. This is the first lesson in our physics first volume book, Electrostatics. Mm. Electrostatics is a subject that deals about charges at rest. Certainly there will be a question, what is meant by a charge? Charge is nothing but it's a cause of a force other than a gravitational force. There are four fundamental forces: gravitational force, electromagnetic force, nuclear strong force, nuclear weak force. Here we are not discuss about nuclear forces. That left us to discuss two forces. One is gravitational and one is electromagnetic. Gravitational force is a interaction. Gravitational force arises between two objects having mass. In electromagnetic, yeah, here I should explain what is the difference between electromagnetic and electrostatic. Electromagnetic, when charge is at rest, that is called electrostatic, or charges at rest. When charges moves, that makes current. When current flows through an object, that makes magnetic, the magnetism or magnetic field around the object. So when charge is at rest, that is electrostatics, that is a subject that deals about charges at rest. When charges move through an object, that makes magnetic effect, where that is called electromagnetic. So we can't explain magnetism without electro nature, since this movement of electrons or flow of charges makes magnetism. So inside the electromagnetic force, electrostatic force comes. Electrostatic force is a force between two charges at rest. Yeah, there will be another question. Well, charges at rest. No one easily answers this question, since charges never be at rest. Then how we can define charges at rest? Yeah, we discuss these things later. Now we have to understand the only thing, that is, what is electrostatics? Electrostatics is a subject that deals about charges at rest. It arises due to interaction between uh, two having property other than mass. Yeah, here we have more thing to distinct gravitational force and electrostatic force. Certainly, electrostatic force is not gravitational force. The reason number one, this is much stronger than gravitational force. Reason number two, gravitational force have attractive nature alone, but this force have both nature, attractive as well as repulsive. So Certainly, electrostatic force is not gravitational force. Another thing, gravitational force arises due to the property of masses. Here, electrostatic force arises due to the reason of charges. That is why I mentioned earlier, charge is the cause of electrostatic force or electrostatic interaction. So, nothing behind the charge than this statement, since charge is an intrinsic. Yeah, this is one of property of charges. We discuss this too later in our class. So now we move to next slide. Learning objective of this class. What is electrostatics? I already explained. What is charge? That too. What is the historical background of charges and electrostatics? Properties of charges, Coulomb's law, superposition principle. Um, I plan to divide this class into two part, since this seems to be much longer to view. To avoid uncomfortable of you, I have planned to divide this class into two. Electrostatics is a branch of electricity that deals with stationary charges. What is charge? I already explained. You can remember. Charge is a reason for a force other than a mass. Since mass is a reason for the gravitation force, charge is a reason for the electrostatic force or electromagnetic force or electric force. This force is that means an electrostatic force is totally different from gravitation. I already mentioned you, since it differs in terms of magnitude with gravitational, since the electrostatic force is much stronger force compared to gravitational force. Another one, electrostatic force have two nature, attractive as well as repulsive, but gravitational force is only attractive. Historical background of electric charges. 2 millennia ago, Greeks noticed that amber, after rubbing with animal fur attracted with small pieces of leaves and dust, the amber possessing this property is said to be charged. Another one interesting thing, this amber or rod is called electron in Greek. That is why charged particle at the time called electron, that is the mm, composite particle, one of composite particle of atom that have negative charge. Yeah, yeah. Here one thing I have to explain you. Since this universe made up of matter is made up of atoms. That atom consists three different fundamental particles: proton, neutron, electron. Proton is positively charged, electron is negatively charged, neutron is chargeless. Universe is made up of atom. Atom consists matter consists atom. Atom consists these charged particles. So universe is in this universe, everywhere there will be matter as well as there will be charges. In this universe, wherever you go, you can meet matter. Wherever you go, you can meet charge. So charge is everywhere in this universe. This is a simple experiment about historical background of electric charges. In this first diagram, you can see two rods. One is rubber and one is glass. Yeah, you can see in rubber rod there are negative signs. In glass rod there are positive signs. Mm. That means rubber is negatively charged, glass is positively charged, and there are two arrow towards each other that represents rubber and glass are moving towards each other. That means attractive force happens between rubber and glass. So we can easily identify opposite charges have attractive nature. Opposite charges have attractive nature. Whenever we get together a positive and negative charge that move towards each other, there will be an attractive force. In diagram B, there are two rods again, both are rubber, both are negatively charged. You can see the red arrow, both are away from each other. That represents there is a force repulsive acting between rubber. Similarly, we can identify when same charges get nearer to each other, there will be a repulsive force act between them. So, opposite charges attracts, same charges repulse. Very simple. Opposite charges attracts, same charges repulse. Yeah, this slide explains what I told earlier. Yeah, this one is very important. If the net charge is zero in the object, it is said to be electrically neutral. Here, you have to remember one thing. A few minutes before, I mentioned charges everywhere. If charge exists everywhere in this universe, why there is no electrostatic force or electromagnetic force between Earth and Moon? Yeah, uh, between Earth and Moon, only gravitational force exists. Why there is no electrostatic force? As macroscopic objects like Earth and Moon, the net charge is zero in those objects. Yeah, even small objects. If you take an atom, hydrogen, there will be only one proton inside the nucleus. There will be one electron around the nucleus. Both have uh, equal magnitude in equal magnitude. That means proton and electron have charge in equal magnitude. That means charge is compensated. So hydrogen atom is electrically neutral. This is not only for hydrogen atom. For every atom, there are equal number of protons and equal number of electrons. So every atom is electrically neutral. So this is due to the symmetry of nature. Every macroscopic object maybe or may not be electrically neutral, but probably every macroscopic objects electrically neutral. That is why Earth and Moon are electrically neutral. There is no electrostatic or electric interaction between Earth and Moon. Yeah, here we go deep. Since attractive nature alone due to the gravitational force. There is no further mass types. That is why there is net mass is zero for any object. Just for fun. So there is no mass types. There is no net mass is zero for any object. So gravitational force exists between any object having mass at even infinite distance. But electric interaction exists between objects having charged or objects uh, are not electrically neutral. So, if there are two objects A and B, there will be gravitational interaction, but there may be or may not be electrical interaction. Charging the objects through rubbing is called triboelectric charging. Basic properties of charges. First property, charge is an intrinsic property. This is a very interesting property since you can ask what is the color of charge. My answer is I don't know. What's the shape of charge? Again, my answer is I don't know. Can we touch charge? My answer is certainly I don't know. Um, then uh, whatever is the question, can we pluck out the charge from the particle? Mm, yeah, my answer is I don't know. Since charge is an intrinsic property, no one explained what is the color of charge, what is the shape of charge, or is what can we pluck out the charge from the particle also. Charge is an intrinsic in nature. No one uh, define it define it in a in a perfect way. Yes, charge is an intrinsic. Yeah, again, mm, how? Yeah, I have a statement. Similarly, mass. If someone asks you what is called mass, the quantity of matter, if the answer is yours, certainly it's wrong. Since mass is an intrinsic, you can't explain it correctly. You can't explain it. Mass is an intrinsic property. Since you can't define it, there is another one intrinsic property that is called spin. These are the fundamental or these are the very important intrinsic property of matter: mass, charge, spin. You can't define what is charge, what is mass, what is spin, how it comes, how it goes, how it happens, or anything. We can utilize or we can find the properties and other things, but we can't explain what is charge and what is mass and what is spin, since charge is an intrinsic. Consideration of charges. Total electric charge in this universe is constant. This statement is mm, charge never be increased as well as never be decreased. That is, charge can neither be created nor be destroyed. In a reaction, uh, before reaction charge number equal to after reaction charge number. That means charge cannot be created, cannot be destroyed. Next one, quantization of charges. Uh, Charge Q on any object is equal to an integral multiple of this fundamental unit of charge E. The equation for this statement is Q equal to Ne. Sense of integral multiple, we are having N equal to 0 or plus or minus 1 or plus or minus 2 or plus or minus 3. You may have a question, or I will ask a question. Is there any possibility of quantization of masses? No, since um, I already mentioned you, the ampere rod in Greek is called electron. The time they have known this charged particles are electrons. So whenever that is why the subject name is electrostatic. That is, interaction is electric interaction. Everything since the charged particles are electrons. When these particles moves, we are having the effect of electric phenomena. So the field electron is the fundamental unit. There is another one. There is force between two charges. Uh, Coulombs. Coulomb found a law that governs force between two charges. By that law, one can define exactly the unit of charge. The unit of charge is coulomb. This coulomb is much large compared to the charge of an electron. So this coulomb is made up of more number of charges, more number of electrons. That means 1 coulomb of charge is made up of 6.25 into 10 power 18 electrons. So every total charge is made up of integral multiple of this unit charge, electrons charge. Similarly, proton charge. Since both are equal, that is why this property arises here. Quantization of charges. Every charge, every total charge is made up of integral multiple of unit charge. That is charge of an electron. Since you know Avogadro principle, 1 mole of matter consists 10 power 23 atoms. If the atom is hydrogen, there will be 10 power 23 electrons. So in 1 mole of matter, there will be more number of electrons. For 1 mole of charge, we can define charge in coulomb, but it consists more fundamental unit of charges. So Q equal to Ne. Uh, you can understand here that is coulomb is much larger unit compared to electron uh, charge of an electron. Since we are using in this book, or we are using practically micro coulomb, nano coulomb values. Robert Millikan found charge of an electron as 1.6 into 10 power minus 19 coulomb by his famous experiment. Similarly, charge of proton equal to 1.6 into 10 power minus 19 coulomb. Electron have the negative signs. electron have the negative sign, proton have the positive sign. Example 1.1. This is very simple example from your book. The question is calculate the number of electrons in 1 coulomb of negative charge. Here they have given negative charge, so it's certainly made up of electrons. According to quantization of charges, Q equal to Ne, where Q is the total charge, N is the number of charges, E is the charge of an electron. Here we have to find N. So the equation becomes N equal to Q by E. Uh, Q is 1 coulomb, E is 1.6 into 10 power minus 19. If we put this data in the equation, we get 6.25 into 10 power 18 electrons. So 1 coulomb of charge is made up of 6.25 into 10 power 18 electrons.